Hello, so today we're looking at factoring polynomials again. So let's see what we're asked today. So we're asked to factor the following. All right, so in part A, 4x plus 4y minus 2y minus 2x. Interesting. There's a couple of ways we can factor this depending on how we group things. All right, let's pick a color and let's give this a try. Okay, so things are grouped quite nicely at present. So in the first two terms, you can factor out a 4, and we're left with 4 times x plus y. In the second two terms, we can factor out a negative 2, and we're left with y plus x, or x plus y. Okay, let's scroll over. Okay, so we have 4 times x plus y minus 2 times x plus y. Okay, so this equals, we have 4x plus y's and negative 2x plus y's. So we can do this. 4 minus 2 times x plus y. And this equals 2x plus y. This is one way to simplify. Another way is to group the x's and y's together and see what we get. So where can we do that? We don't have a lot of space. Let's do it over to the left. All right, so another way, so we use a different color. We started with 4x plus 4y minus 2y minus 2x. Let's group the x's. So we have 2x. Let's group the y's plus 2y. Then we have a common factor of 2. We get 2 times x plus y. That's another way of doing part A. All right, so let's look at part B. So again, how can we do this? Again, it depends how we group things. Interesting. Well, let's see. We got 5s, we got A's, we got Y's, we got C's. Currently, it looks like the way it's written, things are grouped in such a way that in the first, we have a common factor of A. In the second grouping, second pair, we have a common factor of B. Third pair, we have a common factor of C. Why don't we see if we can use this to our advantage? All right, so this equals, let's factor out the A. So then we have negative 5 plus y. Okay, great. Plus, let's factor out the B. And what do we get? We get b times negative 5 plus y. All right. Plus, in the third pair, factor out the c, and we have c times negative 5 plus y. Whoops, y. Okay, that looks good. So now this negative 5 plus y is common. Let's factor that out and see what we're left with. So if we factor that out, negative 5 plus y, what do we have? We have a plus b plus c. It looks like we factored. Again, I'm sure there's other ways we can factor this. We can look at groupings where we're grouping all the y's together and everything else together, possibly, or the 5s, because 5 is common. But why don't we try one more other way of factoring this over here? Let's pick a different color. So let me rewrite it. Negative 5a plus ya, negative 5b plus yb, negative 5c plus yc. Let's group everything with 5s together. So we have negative 5a, negative 5b, negative 5c. All right. Plus, and everything with y's. Ya plus yb plus yc. Okay, so we can factor out the negative 5. We're left with a plus b plus c in brackets plus. Let's factor out the y. We're left with a plus b plus c in brackets. A plus b plus c is common. Let's factor that out. And we have negative 5 plus y. So same thing. That's a good check. All right, let's have a look at C. So far I've shown you two different ways to factor our polynomial that's given, but we don't have to factor things in two ways. As long as we get it right the first way, that's all that matters. So let's have a look at C. X to the power 4 minus 6x squared plus 9. So this actually looks like a quadratic in some ways, where our new variable is x squared. So if we let y equals x squared, then let's do it over here. So let's see. X to the power 4 minus 6x squared plus 9 actually equals y squared minus 6y plus 9. This looks like a perfect square to me, so let's factor it and see. Y, good. So, and we know y is x squared, so let's put that in there, x squared minus 3. Good, so x squared minus 3 is actually a difference of squares. X minus root 3 times x plus root 3 whole squared. So we can either leave it like that, or we can rewrite it as x minus root 3 squared times x plus root 3 whole squared. So that's one way of factoring it. And I think that's the easiest way to factor that polynomial. All right, so now let's look at D. Let's do D over here to the side. D. So D is y to the power 4 minus 16. All right. So again, this looks like a difference of squares, so we can let x this time equals y squared. Then what do we have? This actually equals x squared minus 16. This is clearly a difference of squares. The factors as x plus 4 times x minus 4. But we know x equals y squared, so let's plug that in. Y squared plus 4 times y squared minus 4. This second factor is again a difference of squared, so let's factor that. So x squared, y squared plus 4 remains as is. This difference of squares factors as y minus 2 times y plus 2. And we're done. Let's have a look at E. Okay, it's starting to get messy now. Let's do E right here. Okay, so we have negative z to the power 8 plus 9 times z to the power 6. Okay, so first off, we have z's common in both terms. So definitely z is going to factor out. What exponent of z? What's the smallest exponent? It's 6, so probably z to the 6 will factor out. If we do that, what are we left with? We're left with negative z squared plus 9. All right, so equals, let's rearrange the terms in the bracket to 9 minus z squared. So now we have a difference of squares in the bracket. So we can factor that. We know how to factor a difference of squares. 9 is 3 squared, z squared, it is z squared. Since it's a difference of squares, we put a plus and a negative in there, and we factored. Excellent. All right, so F. Where should we do F? Okay. This is more of a problem in space management. Okay. Oops. Let's find some space. Oh dear, making a mess of the board. We have some space there. Okay, let's do this over to the right. Let's pick a different color so we don't get confused. Back to blue. F. So part F, what do we have? We have, let's write it out, x to the power 6 plus 8x cubed plus 15. All right, let's zoom out, or zoom in a little bit. All right, so for this one, I'm going to, so I notice we have x to the power 6 and an x cubed. So how are 6 and 3 related? They're related by a factor of 2. So 6 is 2 times 3. And we know we have this property of exponents. Law x to the power m plus n is the same as x to the m times x to the n. So in our case, x to the 6 equals x cubed times x cubed, or x cubed all squared. So let's let y equal x cubed. If we do that, then our polynomial becomes y squared plus 8y plus 15. Now we can factor this quite nicely. Okay. What are the factors of 15? 5 and 3, and when you add those together, you get 8. So y plus 5 times y plus 3 is the factorization of y squared plus 8y plus 15. But we know that y equals x cubed, so let's plug that in there. So we have x cubed plus 5 times x cubed plus 3. Good, so I'm going to leave it there. It's probably possible to, it is possible to factor x cubed plus 3 and x cubed plus 5, but we're going to leave that today because it doesn't factor nicely. We don't have nice integer coefficients. So that brings us to the end of our session today. If you have any questions, please feel free to send us a note at info@raisemymarks.com or give us a call day or evening, and we'll be happy to answer your questions. Thank you for watching, and we look forward to seeing you again.